As an introduction, Fortetropin is an all-natural proteolipid complex made from fertilized egg yolk and has been demonstrated to lower circulating myostatin levels. In young men, Fortetropin supplementation has been shown to increase lean body mass compared to placebo. It's also been shown to decrease ubiquitin expression and increase mTOR signaling in skeletal muscle. The purpose of this experiment was to examine the effects of 21 days of Fortetropin supplementation on the rate of muscle protein synthesis in healthy older men and women. We tested the hypothesis that compared to placebo control, Fortetropin supplementation will result in an increase in the fractional rate of muscle protein synthesis. So we use a method by which the use of heavy water can label non-essential amino acids during synthesis. And this graphic demonstration here demonstrates that the deuterium on heavy water exchanges with the hydrogen during synthesis. And this is an example of the synthesis of alanine. So during the synthesis of this non-essential amino acid, you can see that potentially there are 4 hydrogens that can be replaced with deuterium. And then once labeled, the non-essential amino acid is then incorporated into the synthesis of new proteins. This allows for the natural label of newly synthesized proteins throughout the body and potentially allows us to examine the rate of incorporation of these labeled non-essential amino acids to measure the rate of muscle protein synthesis. So typically for the use of heavy water labeling, the subject simply has to drink a small amount of heavy water. And in this way, we can measure for the short term or longer term. It really depends on the rate of turnover of proteins of interest. For skeletal muscles, because they're relatively slow in turning over, we recommend about 2 weeks or more so that the incorporation of the label into newly synthesized muscle proteins can be detected. We then collect the sample, and in this case, muscle was collected. Blood can also be measured, and we can measure the rate of synthesis of newly synthesized proteins that may be secreted into the circulation. We can isolate the molecule of interest. We perform a mass spec analysis of the sample. Then we apply informatics software to calculate flux rates and analyze the data to generate functional kinetic results. The rate of protein synthesis may be measured over hours, days, or weeks, depending upon the sampling time. This is a representation of that. In the first case, subject drinks heavy water. After a period of time, we sample the tissue of interest, and then we isolate the peptides after fragmentation of the protein, and then analyze it by mass spec. And we look at the distribution of where the label is in each of these peptide fragments, and then we can apply our software to examine which specific proteins have been synthesized. In this way, we can measure the rate of synthesis of different ontologies of muscle proteins. And you can see here it's possible, once we have a muscle sample, we can measure the rate of synthesis of mitochondria, myofibrillar proteins, Z-band contractile proteins, nuclear proteins, extracellular matrix proteins, muscular proteins involved in muscular dystrophy, and cytosolic proteins, as you can see here. In this study, we used heavy water to measure the rate of synthesis of multiple proteins muscle protein ontologies in 10 men and 10 women, average age of 66.4 years. All subjects received 30 milligrams of D3 creatine prior to submitting a fasting urine sample to determine muscle mass at baseline. The subjects were randomly assigned to Fortetropin supplementation or placebo. In this case, a cheese powder placebo was used to match the macronutrient content of Fortetropin for the 21-day duration of the study. On days 1, 2, 3, and 4, subjects ingested 50 mLs of 70% heavy water TID, followed by BID ingestion for 17 days. In this way, we can increase the enrichment of water rapidly and then maintain the enrichment of water during the period of time of interest. Saliva samples were collected to determine body heavy water enrichment on study days 4, 7, 14, and 21. Blood samples were collected on days 1 and 22 for determination of circulating myostatin levels. On day 21, a muscle microbiopsy, which was about 10 milligrams in size, was taken from the vestus lateralis and rapidly frozen. In-solution digestion with trypsin was performed on SDS-soluble proteins prior to LCM-SMS analysis using 27-minute gradient runs. Fractional synthesis for each subject was calculated with average body water used as the precursor enrichment. Statistical analyses were performed for the multiple groups of proteins by the t-test with the Benjamini-Hochberg correction for multiple comparisons, as well as the binomial test on magnitude of change for gene ontological groups of myofibrillar, cytoplasmic, and mitochondrial proteins. This shows the scheme of the study, and you can see again we gave each subject D3 creatine and then later collected a urine sample, so we had baseline muscle mass values. During the period of time, you can see with this red line, heavy water was administered to each subject, and during the intervention period, subjects received either the Fortetropin supplementation or the placebo. And you can see that saliva was collected, urine was collected, muscle was collected, and then on day 21, a muscle biopsy was taken. And these are the data for the body water enrichments. And you can see these are the individual values at the top and at the bottom of the saliva body water average values. Importantly, there were no difference between a placebo and Fortetropin, which we did not expect. But importantly, you can see by day 4, body water enrichments were about 1% of total. And you can see that it was fairly stable during the 21-day period. And this allows us to determine and use the body water enrichments for the calculation of muscle protein synthesis. Importantly, the measures of muscle protein synthesis that we measured were for the entire period of labeling. It wasn't a single time. The 21-day biopsy actually is an average of the rate of synthesis of new proteins over that 21-day period. These are the fractional synthesis rates of 38 myofibrillar proteins in control and Fortetropin groups. And this is the only slide that I'll show like this, because what you can see is the cheese powder or placebo for each of these individual proteins. And you can see, for example, this is titin, myosin 7. There are a number of different myofibrillar proteins. But what you can see is that the blue represents placebo, Fortetropin represents the Fortetropin supplementation, and for almost every single protein, you can see that Fortetropin rates of synthesis were greater. What I'll show you from now on are essentially the differences of myofibrillar protein fractional synthesis rates compared to Fortetropin. So that, for example, all of these proteins, for all of these proteins, there was a greater rate of synthesis on day 21 for the Fortetropin supplements compared to placebo. And in fact, for 33 of 38 proteins, we saw a greater rate of synthesis in the Fortetropin group compared to control. The mean magnitude of the difference was 14%. And as you can see, that for the proportion of increased proteins using a two-tailed binomial test, the value, it was highly significant. These are the data for the cytoplasmic proteins. So again, the cytoplasmic protein fractional synthetic rate increased for 36 of 44 proteins in the Fortetropin group compared to control. The mean magnitude of difference was 13%. And again, you can see that overall there was a fairly strong signal from the Fortetropin group. And again, for 36 out of 44 proteins, there was an increased FSR, and this was highly significant. And this is showing the mitochondrial protein fractional synthetic rate increase for 15 of 19 proteins in the Fortetropin group compared to control. The mean magnitude of difference was 18%, and this was highly statistically significant. So in summary, saliva body water enrichments reached a plateau of about 1.5% as expected for this labeling protocol. There were no effects of Fortetropin on circulating myostatin levels. There was a significant relationship between 21 circulating myostatin, between day 21 circulating myostatin and average protein FSR with an R of 0.5327. We're not exactly sure what the significance of this is, because it kind of goes in the opposite direction that you would think. It may also tell us something about the fact that circulating myostatin proteins may not be the entire story. But the fractional synthetic synthesis data includes myofibrillar, cytoplasmic, mitochondrial, extracellular matrix, endoplasmic reticulum, membrane, and nuclear proteins. Treatment with Fortetropin did not produce a statistically significant increase in the fractional synthesis rate of any individual protein. And that's really because of multiple comparisons. A t-test for comparison after correction for multiple comparisons is really shows no individual values were statistically significant, but the average fractional synthesis for a majority of the proteins in several gene ontologies was higher in the Fortetropin group. As I said, 33 out of 38 for myofibrillar proteins, 36 out of 44 for cytoplasmic proteins, and 15 out of 19 for mitochondrial proteins. This proportion was statistically significant. The overall magnitude of increase was 15%, demonstrating a stimulatory effect of Fortetropin on muscle protein synthesis rates. Fortetropin effects were independent of gender or baseline muscle mass of the subjects. So in conclusion, daily intake of Fortetropin resulted in a consistent 21-day increase in the rate of muscle protein synthesis. This was true of myofibrillar or contractile proteins, sarcoplasmic, and mitochondrial proteins. The data suggest that Fortetropin is an anabolic agent to counter the effects of sarcopenia in older men and women. And obviously, data is needed on the long-term effects on muscle mass, strength, and functional capacity, but these data are highly indicative that Fortetropin has a significant stimulatory effect on the rate of synthesis of muscle proteins.